Hello students, a very pleasant good morning to you all. I am Babisha, your chemistry teacher. Today we are going to study about lesson 10, the continuation of lesson 10, that is matter around us, right? Unit 10, matter around us. In this last video we discussed about the matter, right? So what is matter? That matter, anything in the world that has mass and occupying space is called as matter, right? So where it is located, it's surrounding us, okay? And in the last class we discussed about classifications of matter also, right? So classification of matter, under that topic, what are the things we studied? Matter is classified into two types. What are they? Pure substance and impure substance. Pure substance is further classified into two types. What are they? Elements and compounds. Okay. So elements means it cannot be broken into simpler substance, and we studied some examples also. Copper, oxygen, hydrogen, then carbon, nitrogen, any elements you can write. Okay, not only these three elements. What are the elements, you know? You can write, no problem. Okay, then compounds. Compounds, how the compounds are formed? Two or more elements interact together, it will form a new substance. Okay, that is called as compounds. These compounds can be broken down into elements by chemical reaction. Example, water, sugar, salt. Some example in the last class we discussed, right? So today we are going to discuss about next classification, that is impure substance. Okay, so matter is classified into two types. What are they? Pure substance and impure substance. This impure substance is otherwise called as mixture. Okay, impure substance is otherwise called as what? Mixture. Mixture, you all know, two or more substance mixed together, that is a mixture. Okay, and this mixture, lot of mixtures you can say. Can you say some example for mixture? In our everyday life we are using lot of mixtures, isn't it? So can you say some example? Yes, milk, then sea water, then juice, lot of examples we can see. Okay, so some mixtures we can able to identify. Okay, some mixtures we can able to see, but some mixtures we cannot able to see. Okay, some mixtures we can able to see. For example, water plus oil. Water plus oil you can see, both are mixture, but you can see the separate layers, right? So these types you can able to see the difference, but some mixture you cannot able to see. Some that is sugar plus water, okay, and salt plus water, these type you cannot able to see. So based on this mixture is classified into two types, that is homogeneous mixture and heterogeneous mixture. Okay, so matter is classified into two types. What are they? Pure substance and impure substance. This impure substance is further classified into two types, that is homogeneous mixture and heterogeneous mixture. Okay, homogeneous means uniform composition. Uniform composition means, one example, you take a glass of water. Okay, you take a glass of water and add a spoon of salt. Okay, add a spoon of salt or sugar, anything, and dissolve it well. After few minutes, when you see that glass of water, can you see that salt particle again? You can't see, right? You can see only that water particles. That is a uniform composition, because that salt is uniformly dissolved there. Okay, but you can't feel that taste, right? So that is a uniform composition. Have you understood the difference? So some examples also given in your book, that is sugar plus water and water plus alcohol. These are the examples for homogeneous mixture. Okay, so homogeneous mixture, that is a uniform composition. Okay, and see the heterogeneous mixture. Heterogeneous mixture, these types of mixture you can able to see the difference. Okay, so heterogeneous mixture, that is a non-uniform composition. Okay, it does not dissolve thoroughly, so you can see that difference. Example, sand plus sugar. If you mixed this sand and the sugar, you can able to identify where is the sand, where is the sugar, like that you can able to identify. And one more example, water and oil. So this one also you can identify. So when you mixed this oil in water, it can't be mixed, right? So this oil will be present on the surface of that water, right? So you can see the two layers. So these are comes under heterogeneous mixture. Have you understood? So mixture is mixture or impure substance. Impure substance is classified into two types, that is homogeneous mixture and heterogeneous mixture. Okay, homogeneous mixture, that is a uniform composition. Heterogeneous mixture, non-uniform composition. Okay. So first we are going to study about this mixture. So a mixture is an impure substance. You all know it is an impure substance. It contains two or more kind of element or compound. Okay, this mixture contains two or more kind of element or compound. For example, lot of examples given in your book. See the first example, tap water is a mixture of water and some dissolved salt. So this tap water is an example for what? Mixture. Maybe they will ask in a one more question. Okay. So tap water is a mixture is an example for mixture. Okay. So tap water contains what are the components? Water and some dissolved salt. Okay, potassium salt or sodium salt or chloride salt. Okay, lot of salt mixed in this tap water. Okay, and see the next example. Lemonade. Lemonade is a mixture of what are the things you all know? Lemon juice, sugar and water. The next example for mixture, air. So air contains lot of gases, right? So nitrogen, oxygen, carbon dioxide, water vapor and some other gases. Okay, sulfur, then hydrogen, lot of gases mixed in this air. So air is the example for mixture. Okay, so maybe they will ask, air is a pure substance or impure substance? Can you say? Air is a impure substance because they contain, that is a mixture, right? So they contains lot of gases. Okay, mixture of gases. And soil. Soil is a mixture of clay, sand and various salt. And some other examples also given: milk, ice cream, rock salt, tea, smoke, wood, seawater, blood, toothpaste and paint, or some other examples of mixture. Lot of examples you can say about the mixtures. And see this point, alloys or mixture of metals. This is very important. Alloys or mixture of metals. So alloys means, best example you can say gold ornaments. Okay, gold ornaments. Can you say we are using the gold, right? So can you say this gold is pure or impure? This is impure, not pure gold. Pure gold we cannot make as a ornaments. Okay, for the tensile strength and sternness they are adding this gold in copper. Okay, then only we can use as a ornament. So alloys are mixture of metals. Okay, alloys are mixture of metals. Have you understood? So mixtures means a mixture is an impure substance. Mixture is an impure substance. It contains two or more kind of element or compounds, or both physically mixed together in any ratio. They don't have particular ratio. Any ratio we can add. That is a mixture. Okay. Some examples given in your book. Okay. And LPG. LPG also a mixture. Do you know the abbreviation for this LPG? L means liquefied, P means petroleum, G means gas, right? So LPG, liquefied petroleum gas. So you know it is a highly inflammable hydrocarbon gas. Okay, so for what purpose we are using this LPG? for cooking, heating, and it is also used as a auto fuel. Auto fuel means the vehicles they are using. Okay, and this LPG contains what are the gases? See, this is also important. One more question. It contains mixture of butane and propane gas. Okay, so it contains mixture of butane and propane gas. So listen carefully. Wherever I am saying this is an important question, please note it in your book. Okay, because finally I will ask question from this video. Okay, so it is LPG is a highly inflammable hydrocarbon gas. It contains mixture of butane and propane gas. So LPG contains what are the hydrocarbons? Butane and propane. If you have book, please you underline it. Okay, so these are some more examples for mixture. Lemon juice. Lemon juice contains water, then lemon juice, then salt, right? So this is a mixture. And soil contains clay and some other salts. Okay, and ice cream, it contains salt, then cream. Okay, some flavors. Okay, lot of mixtures present in ice cream also. And on activity given in your book, see, this is very important activity. From this activity box, many questions are asking. Okay, so see, listen carefully. Very simple only. Take some powdered iron fillings and mix it with sulfur. See the first picture. This yellow color substance is a sulfur. Okay, yellow color substance is a sulfur powder, and this black color, grey color substance is a iron. Okay, iron fillings. Okay, so now you have to take this iron filling and sulfur and you should mix it well. Okay, both you have to mix it well. And see, divide the mixture into two equal halves. After mixing these two components, now you can say that is a mixture, right? So after mixing these two components, you have to divide this component into two parts. Okay, and one half you have to keep it rest. Okay, and another half you have to heat it well. Okay, so keep the first half of the mixture as it is, but heat the second half of the mixture. So second half you have to heat it well. On heating, you will get a black brittle compound. So when we are heating, we will get this compound, that is a black brittle compound. So black brittle means easily broken. Okay, so you will get this black brittle compound, that is called as iron sulfide compound. Okay, this is called as what? Iron sulfide compound. So the black compound is iron 2 sulfide. Now see, this is iron, right? So iron plus this is sulfur. This yellow color is a sulfur. So iron plus sulfur gives, we are heating, no? So heat, we will get the new substance iron sulfide. So from this picture you can say which one is mixture, which one is compound. Can you say? So when we are mixed together, that is a mixture, right? The first half is a mixture and the second half we heated, no? One chemical reactions going on, right? So after this chemical reaction we got a new compound. Okay, so two elements, these are two elements combined together to form a new substance, that is called as compound. Okay, so we got a new substance, that is iron sulfide compound. Okay, have you understood? So from this table they can ask what is the color of iron sulfide. What is the color? Black color. Okay, and see, from that activity we can write one table. So iron substance, iron is a what color for iron? Dark grey powder. Okay, iron is a element, this is a dark grey powder. And the effect of magnet, did this iron can attract the magnet can attract the iron? Yes, you all know, right? So it will be attracted to it. Then see the second column, sulfur. Sulfur, the color for sulfur is yellow powder, and the effect of magnet, no effect, right? Powder, that is so none. Okay, then a third one, iron plus sulfur. When we mixed together, first off, okay, when we mixed together, the dirty yellow color will form, right? So dirty yellow powder, and the effect of magnet, here some iron particles are there, no? So that iron particles only can attract. Okay, so iron powder attracted to magnet. Okay, iron powder attracted to magnet. And see the last column, iron sulfide. Iron sulfide, after heating this mixture, the second of we heated, no? So that mixture, that is iron sulfide compound. So this iron sulfide compound is a black solid. It has no effect because chemical reaction takes place. Okay, we cannot get the iron property, we cannot get the sulfur property, so no effect. Have you understood? Then this is a blood. Okay, so do you know this blood is a pure substance or impure substance? Impure substance. Okay, because blood contains the mixture of red corpuscles, plasma, then iron. Okay, so this is a mixture. Okay, so blood is not a pure substance. It contains iron, then red corpuscles and plasma. Okay, then difference between mixture and compound. Difference between mixture and compound. So from this picture itself you can say the difference. So see these two picture. This is a mixture, this is a compound, right? So mixture contains two or more substance. Okay, mixture contains, first difference, mixture contains two or more substance. Here compound contain only one substance. Okay, here the constituents may be present in any proportions. We can add as any proportion, but here the constituent must be present at a definite proportion. Okay, this ratio only. If you are taking water, if we are saying water as a compound, so water, when we are getting the water as the ratio form 2:1. Okay, so a definite proportion only compound will be formed. Okay. Then see the third difference. They show the properties of their constituent. It will show the iron property and it will show the sulfur property. So it will show the property of their constituent. Okay, but here it do not show the property of the constituent element because new substance formed, no? So that a new substance property only it will be show, but it does not show the properties for iron and sulfur. Okay, so do not show the properties of the constituent elements. Okay, then see the fourth point, the components may be separated easily by physical method. So physical method means hand picking method, filtration method, then sieving method, lot of methods are there, right? So use the physical methods, we can separate out the components, but here the constituent can only be separated by one or more chemical reaction. Okay, with the chemical reaction only can be separate out this compound. Have you understood the difference? So first one, it contains two or more substance. Here it is a single substance, and here the constituent may be present in any proportion. Here it are present in definite proportion. They show the properties of their constituent, will show their iron property or sulfur property, but here it do not show the property of the constituent element. The last point, the components may be separated by which method? Physical method, but here compound, it was separated only chemical methods. Okay, chemical reaction. Then an activity given, you should find out the answer. See, we need to find out whether the given compounds are mixture or compound. See, sand and water. Sand and water you can separate out, right? So it is a mixture or a pure substance, mixture or compound, mixture. Okay, then sand and iron fillings, mixture, and concrete we cannot be separate out, right? So it is a compound. Then water and oil we can see 2 layers. So it is a mixture. And salad, mixture. Then water, we cannot be separate out easily, so compound. Carbon dioxide, compound. Cement, compound. Then alcohol also compound. We cannot be, what are the things we cannot be easily separated out? That is a compound. Okay, what are the components we can easily separate it by physical method? That is a mixture. Okay, then types of mixture. So already I told you, most of the substance we use in our daily life, that is called as that's a daily life or mixture. In some we can able to see the components, but some we cannot be able to see the components. So based on this, mixture is classified into 2 types. What are they? Homogeneous mixture and heterogeneous mixture. And homogeneous mixture is further classified into 2 types, that is true solution and alloys. True solution means uniform composition, salt plus water, sugar plus water, we cannot be separate out easily. Alloys also uniform composition. I told you, gold with copper, that is the best example for alloys. Okay, alloys means homogeneous mixture of 2 metals. Okay, alloys means what? Homogeneous mixture of 2 metals. So here true solution, salt plus water, alloys gold and copper. We cannot be able to separate out easily. Okay, but heterogeneous, it is further classified into 2 types, that is suspension and colloid. Okay, what are they? Suspension and colloid. Suspension, we cannot be able to see the 2 layers, water plus oil, then chalk powder with water, chalk powder with water. When we mixed chalk powder with water, after few minutes, when you see that components, you can see the layers, that chalk powder will be settled at the bottom, so you can see the 2 layers. So that is a suspension. Colloid means starch powder with water. Okay, here also the same thing. Okay, the starch, you can see the starch and you can see the difference for the starch and water. Have you understood? And homogeneous, heterogeneous mixture. So what is homogeneous? This is a 4 mark question, so listen carefully. Okay, so a mixture in which the components cannot be seen separately is called as homogeneous mixture. So what are the mixtures we cannot be seen separately? That is called as homogeneous mixture. It has a uniform composition and every part of the mixture has the same property. So the homogeneous mixture example, water plus sugar. Okay, uniform composition, it has same property. After dissolving this salt, you can feel that sugar taste. If you are adding sugar, you can feel the sugar taste. Salt, if you are adding salt, you can feel the salt taste, right? So the mixture has the same properties. Okay, example, tap water, milk, air, ice cream, sugar, syrup, ink, any 2 or 3 examples you can write. Okay, these are the examples for homogeneous. Then heterogeneous, a mixture in which the components can be seen separately is called a heterogeneous mixture. So heterogeneous means any mixture if we can able to see separately, that is called as heterogeneous mixture. Okay, so there we cannot be seen separately, but here we can see the seen separate. It does not have a uniform composition and properties. Okay, just opposite for this homogeneous. Okay, it does not have a uniform composition and properties. So example for this heterogeneous: soil, a mixture of iodine and common salt, a mixture of sugar and sand, a mixture of oil and water, a mixture of sulfur and iron fillings, and a mixture of milk and cereals. Okay, so this milk and cereals or the heterogeneous mixture. Have you understood? So homogeneous means the components can be seen, the components cannot be seen separately. Heterogeneous, the components can be seen separately, and here it is a uniform composition. This one not have a uniform composition. It will shows the mixture properties, but it will shows the components properties. Okay, and some example for homogeneous is tap water, milk, air, ice cream. Here the example for this heterogeneous is soil contains the mixture of iodine and common salt. This one also maybe they will ask in a 1 mark question, so please underline it. Soil, a mixture of iodine and common salt, a mixture of sugar and sand. And these are the example for heterogeneous mixture. Have you understood? And some questions from this video, you should find out the answer. Okay, so see the first question. LPG contains the mixture of dash and dash. Okay, LPG contains the mixture of two gases we studied, hydrocarbon gases. Okay, go through the videos and find out the answer. Okay, so listen students, this 1 mark questions you need to write in this homework note. Okay, home assignment separately you have one note, no? For that note you should write this 1 mark question. Okay, this 4 mark question and all, if you have book means you know need to write in the class note. If you don't have book means you must write in this question in your class note. And the week of the end you will come at a school, no? So at that time you should submit this homework note and classwork note also. Okay. So see, second question, blood is a dash substance. Blood is a pure or impure? So find out the answer. Okay. And what is the color of iron sulfate? From that picture, you should find out the answer and write down here. And fourth question, tap water is an example for dash. It is a homogeneous or heterogeneous? Okay, tap water is an example for dash. Homogeneous or heterogeneous? Then see this question, 4 mark question. How are homogeneous solution differ from heterogeneous solution? Explain with example. It is given in your book page number 116 and 117. So those who don't have book, please note it from this video. Okay. So answer, you have to start from here. Homogeneous and heterogeneous mixture is there in your book. Okay, so you have to start it from here. A mixture is in which the components cannot be separately is called a homogeneous mixture. Then this paragraph fully here, when you are writing the examples, any 2 or 3 examples enough. Okay, tap water, milk, air, ice cream, this much enough. Okay, then this paragraph fully, here also you can write any 2 or 3 examples. Soil, a mixture of iodine and common salt, a mixture of sugar and sand, a mixture of oil and water, this much enough. This diagram no need to draw. Have you understood? So how the homogeneous mixture differ from heterogeneous mixture with example, have to start from this paragraph and up to this paragraph. This diagram no need to draw. Okay, have you understood? So don't forget this 1 mark question, you should write it in your homework note. Okay, home assignment note. And this question study and write. Okay, so study well. I hope you all understood this portion. So study well, don't waste your time. Okay, thank you.